vertical motion models are how we determine the path that an object will travel as it falls, or as it's thrown or kicked, as it jumps. All right, so anything that is traveling through the air without being acted on by an outside force. All right, now the vertical motion model is going to use the same formula as standard form, but we just change up the letters. So instead of f of x, we use h of t. All right. Our a value is always negative 16 because that is the movement of gravity. And instead of the letter x, we use t to describe time. All right. So then we have what's called the v naught. This stands for the velocity, the initial velocity. It's usually positive because usually there's some kind of push upwards, which causes your starting value to be a positive number. Although you can throw something straight down. Like, say I had some goodies like Easter egg that I didn't like, and I just threw it on the ground. Ooh, or someone's cell phone when they make me mad in class. And I just throw it on the ground, right? That initial velocity technically would be 0, but I'd when it leaves my hand, it would have a move, like a velocity, a speed downwards. And then at the end, we have our initial height, which we use h naught to describe that. That h naught is the y-intercept. Okay, it's where you start tracking the time because that's when it leaves your hand. So if we think about this, right? So here's some parabola traveling through here, okay? You have your h naught here. All right. You have your h final, whichever hf is, all right? And so when you have this parabola, if you're going to find some maximum height, all right, the maximum height occurs at the vertex. Man, my pen is horrendous. So the maximum height is equal to the vertex, or on the vertex, okay? Where the x value of the vertex is the time that it takes to get to the maximum height, and the y value of the vertex is what the maximum height is. So in order to find the time that it takes, you need the x value of the vertex, which is actually whatever your axis of symmetry is. So you guys learned about the axis of symmetry as x equals negative b over 2a. The only difference with the vertical motion model is instead of using the letter x, we're using t to stand for time. And then in order to figure out what that maximum is, when you know how long it takes, once you know your time value, you plug it back into the equation to solve for h. All right, so here we have a problem that I came up with. All right, I'm not very creative, don't judge me. So Miss C and Miss Weiler flip a coin to decide who gets to go to the bathroom first during our lunch break. It's not true, we're usually a little more polite about it, but you know what? We're going to flip a coin this time. They can model the path that the coin follows through the air using the equation, blah, 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 right? Where h of t is the height of the coin in feet, and t is the time in seconds. How long does it take for the coin to reach its maximum height, and how high did Miss C lob the coin into the air? All right, so this 30 is the initial velocity. So that's how fast the coin was traveling when it left my thumb. And the 3 is the height. So I was holding my hand 3 feet above the ground when I launched that coin. All right, so how long does it take for the coin to reach its maximum height? I'm going to go ahead and use the formula I gave you on the last slide, the t equals negative b over 2a. All right, so our b value is our v naught, so 30. So I'm going to say negative 30 over 2 times my a value. In these vertical motion models, it's almost always negative 16 because we're talking about feet per second squared. Now, if I'm looking for an exact amount, 30 divided by 2 is 15. So I have negative 15 over 16. But if somebody were to ask me, yo, Miss C, how long did that take? And if I told them 15/16 of time, oh, the negative's going to cancel out, by the way, because it's negative and a negative. If I told somebody 15/16 of a second, they'd look at me like I'm a crazy person. I mean, let's be honest, they already look at me like I'm a crazy person. But they'd look at me like I'm even crazier. They'd be like, what? So what we do is we use an approximation, because in reality, almost nobody is ever like, oh yeah, that's a fraction of this time. Unless it's one of the convenient fractions, like a quarter. Here, when I put it in the calculator, I get 0.9375. That's not even an approximation, that's an exact. So I'm going to get rid of those squiggles because I put the exact amount there. All right, so for that coin to leave my hand and get to its maximum height, it takes it just shy of a second. All right. So then the next part is seeing how high in the air it is. So I'm going to take that t value, and everywhere where I see the letter T, I'm going to put in 0.9375. And I'm probably going to regret how long and annoying that number is to write. I'm going to zoom in a little bit. Oh, jeez. Just so it's easier for me to write. This tablet doesn't like small motions. Okay, so negative 16 times that t, 0.9375. While I'm filling this out, just a reminder, if you use a TI calculator, they have a button that says stow on it, and you could store annoying numbers like 0.9375. And if you hit the second and the reclaim button there, it'll hit or put that 0.9375 anywhere you want it, so you don't have to retype it 6 billion times. It's one of my favorite calculator features. If you have a Casio, sorry, I don't know anything about those. But there we are, I have this, okay? So now I'm going to actually calculate h of 0.9375. And I'm going to hope and pray that the numbers that come out of it are less annoying. So what I actually do is I go through, I don't know why I put an equal sign there. I actually go through and I calculate this part so that if I do get an annoying number in that first part, I don't have to write it down. Don't judge me, I'm lazy. Okay. So 30 times 0.9375 is 28.125. I'm just using my little computer calculator. All right, so now I'm going to try this first part. So I'm doing 0.9375, and I'm timesing it by itself because you have to square it before you could times it by that negative 16. Oh, I need to actually type in my calculator for it to work. That's a novel idea. So 0.9375, and I'm squaring that, which means I times it by itself. I got a hideous number, 0.8789065. Ain't no way in heck. Oh, when I times it by 16, it wasn't so bad. But I'm lazy. I don't like writing all these numbers out. So I'm actually holding that in my calculator. I'm not hitting clear. I'm not hitting any buttons. I'm just holding it. Because I'm going to take this number and I'm going to add these other values to it. What I find kids tend to do, which many of you will probably do on your final and mess yourselves up with, is you guys tend to write this whole equation out exactly as you see it in your calculator, and you don't understand how your calculator is programmed. And so what will end up happening is you guys will mess up your order of operations and get a wrong answer. In fact, a lot of the times when I go to make tests, I'll do something like that. I'll type that exactly as I see it, and then put whatever answer gets spit out there. Because Miss Caswell is mean and unacceptable. All right, so 0.9375, the height, the maximum height that it would reach would be 17.0625 feet in the air. So we're going to pretend that Miss Weiler and I were standing outside of a porta potty or something so that there's enough room in the air. It doesn't hit a roof. Okay, this would be like if I actually flipped a coin, because I'm not very good at it, and it would travel very high up. If I did this in a building, it would hit the ceiling, right? Because ceilings aren't 17 feet tall. and then it would come back down, and Miss Weiler would win because of the mulligan. There we go.